Dear students, Chapter 2 Polynomials, Exercise 2.1, and we are going to discuss about the examples as well. Let's move to the zeros of the polynomial concept. In the first exercise, only zeros of the polynomial, how to identify it algebraically as well as graphically. So first, you know what is the polynomials. In grade 9 itself you have learned. Here you are going to learn how to find the zeros of the polynomial. In a polynomial, if a value of the variable which makes the whole polynomial value as 0, which is known as the zero of the polynomial. For example, if p of x is the polynomial, means for all the values of x that makes the polynomial equal to 0 is known as the zero of the polynomial. For example, if I am taking m and n, two real numbers, when I am replacing the x values by m and n, if the polynomial value becomes 0, that m and n are said to be the zeros of the polynomial. Let's take an example. P of x, a linear polynomial I am taking as x plus 8. If I am random values I am giving for x as 0 first, then P of 0 is equal to 0 plus 8, but 8 not equal to 0. Give some other values like 2. P of 2 is equal to 2 plus 8, which is equal to 10. Again, it is not equal to 0. Let's check with negative 8. When I'm replacing by negative 8, it's negative 8 plus 8, which is equal to 0. So by replacing negative 8, the value of the polynomial is becoming 0. So it is the negative 8 is known as the zero of the polynomial. Now we are going to discuss about the different types of polynomial and their zeros. First comes the linear polynomial. Linear polynomial means we know that the degree of the polynomial is 1 and their general form is ax plus b. In ax plus b, the variable is x. The degree of this polynomial is 1. When the degree of polynomial is 1, it has the straight line in the graph and it intersects the x-axis at one point. Where it intersects the x-axis at one point, that point is known as the zero of the polynomial. So it has only 1, 0. So this is the point you want to know. Since it is a linear polynomial, definitely it intersects the x-axis at one point and it has only 1, 0. We'll take one linear polynomial y is equal to x plus 3. To find out the value of the 0, let's consider the value of the polynomial equal to 0. So x plus 3 equal to 0. When x plus 3 is equal to 0, x is equal to negative 3. This negative 3 is the 0 of this polynomial. When I'm replacing this x by negative 3, you can see here negative 3 plus 3 equal to 0. So x is equal to negative 3 is the 0 of this polynomial. You can see in the graph, the linear polynomial makes a straight line and then it intersects the x-axis at negative 3. So where the zeros of the polynomial can be identified from the graph by looking at where the graph is intersecting the x-axis. So here the straight line is intersecting on only one point at negative 3, that is the zero of the polynomial. Next we are going for the quadratic polynomial. The quadratic polynomial degree is 2. So the general form of the quadratic polynomial is ax squared plus bx plus c. A not equal to 0. You know that quadratic means definitely the highest power of the x must be 2. If it is 0, x squared means the term not there. So definitely the a must not be equal to 0. When the square term exists only, it is said to be the quadratic polynomial. Quadratic polynomial gives always a U-shaped curve in the graph. The curve is known as the parabola. And it intersects the x-axis at 2 points. And when it intersects at the x-axis at 2 points, the 2 points are said to be the 2 zeros of the quadratic polynomial. Let's consider an example. Y is equal to y is equal to x squared minus x minus 2. To find the zeros of the polynomial, consider y is equal to 0. So x squared minus x minus 2 is equal to 0. Now I want to factorize this one to find the number of zeros and the zeros exactly. So I'm going to use the splitting at middle term method. X squared and minus 2, I'm going to split the negative x into two parts. So by multiplying, I want to get negative 2. By adding, I want to get negative 1. The two numbers are 1 and 2. 1, 2 is 2. 2 minus 1 is 1. Since this sum number is negative, big number here is negative. Plus 1, so plus x, minus 2, so minus 2x. Now, take the common factors from the two terms. From the first term, x is common. So x plus 1. And here negative 2 is common. X plus 1. Take this x plus 1 commonly outside. So x plus 1. The next bracket, x and minus 2. Which is equal to 0. When we are multiplying the two numbers, if the value is 0 means one of the number is 0. Either x plus 1 is equal to 0 or x minus 2 is equal to 0. When x plus 1 is equal to 0, x will move to the next side as minus 1 or x value can be 2. You can see here x having two values, minus 1 and 2. That means negative 1 and 2 are the two zeros of this polynomial. Let's check with the graph. You can see here in the U-shaped curve, the curve is intersecting at negative 1 as well as at 2. So these two are the zeros of the quadratic polynomial. Okay, so where the curve is intersecting the x-axis, that particular points are known as the zeros of the polynomial. So what we have done here by factorizing is algebraic method. In the graph also you can identify that is graphical method. Now we are going for the cubic polynomial. Cubic polynomial means the degree of the polynomial is 3. So ax cube plus bx squared plus cx plus d is the general form of the cubic polynomial. Here again, a should not be equal to 0. And since it is a cubic polynomial, degree is 3, definitely the curve must intersect the x-axis at 3 points. So if the curve is S-shaped curve, it intersects the x-axis at 3 points and it has 3 zeros. Let's consider an example, x cube minus 2x squared minus 3x. To find the number of zeros, first you make y equal to 0. X cube minus 2x squared minus 3x is equal to 0. Here you can see all the terms have x. So we'll factorize like we'll bring the x commonly outside. X squared minus 2x minus 3 equal to 0. As I said before, when we are multiplying the two numbers, if the value is 0 means either first value is 0 or the second is 0. Okay, keep the x equal to 0 as it is and we will factorize the second one. X squared minus 2x minus 3 equal to 0. Okay, here again we want to factorize this using the splitting at middle term method. I want to split the negative 2. Some number, product number is negative 3 and some number is negative 2. The two numbers are 1, 3 is 3. And since the sum number is negative, so big number is negative here. So plus x minus 3x and minus 3, which is equal to 0. Take the x commonly outside. So x plus 1 and negative 3 outside. So x plus 1 equal to 0. X minus 3 and x plus 1. So this x plus 1 I have written here and x minus 3 equal to 0. Okay. When x minus 3 equal to 0 or x plus 1 equal to 0. When x minus 3 equal to 0, this negative 3 goes to the next side as positive 3 or x plus 1 is equal to 0 means x is equal to negative 1. So list out the zeros. First we found x as 0. Next is negative 1 and then 3. So these three are the zeros of this polynomial. Let's check with graphically. You can see here the graph intersects the x-axis at negative 1, 0 and positive 3. So for a cubic polynomial, the degree is 3. So the curve intersects the x-axis at 3 points. The 3 points are known as the zeros of this cubic polynomial. Next is biquadratic polynomial, which means the degree of the polynomial is 4. So definitely you understood now. Degree is 4 means definitely the graph of the polynomial should intersect the x-axis at 4 points. And the zeros of the biquadratic polynomial is 4. So 1, 2, 3 and 4. So biquadratic polynomial has the 4 zeros. Next is quadratic polynomial with coincidence points. Sometimes the polynomial may intersect the x-axis at the same point, like here x is equal to, you can see here -1. The curve is intersecting at -1 only, but it is a quadratic polynomial, which means that definitely it should have 2 zeros, which means that the x value, what it takes is -1 and -1. We want to consider both as a single point only. So these two examples tells you the quadratic polynomial or any polynomial may have the coincident points also as a zeros. Next is quadratic polynomial with no zero. It's not necessary every time we want to get a real number as the zeros. Sometimes you will be learning in a quadratic equation lesson as how the imaginary values may come for the quadratic equation. So here, sometimes the curve may not intersect the x-axis, which means that they don't have the zeros. So no zeros for these polynomials, which means for any value of x, the quadratic polynomial not going to be as equal to 0. Okay, so it has no zeros. Next comes our example questions. So from this graphs, you want to find out the number of zeros for the given polynomial. So here, you can see the graph is intersecting the exact x-axis at 1 point, so it has 1 0. Here it is intersecting the x-axis at 2 points, it has 2 zeros, and it is intersecting the x-axis at 3 points, it has 3 zeros. And here again, intersecting the x-axis at 1 point, and here you can see it has the coincident point. So you want to consider as 1 point, 1 0 only. And here 1, 2, 3, and 4. So this curve have 4 zeros. Next, we are moving for the exercise problem. In exercise first question, again, you want to find out the number of zeros of the given polynomial from their graphs. So the first one is not intersecting at any point in the x-axis. So it doesn't have the zeros. So no zeros. And in the second question, you can see it is intersecting at 1.10 and it is intersecting at 3 points. So 3 zeros. And here the parabola intersecting the x-axis at 2 points, so 2 zeros, and 1, 2, 3, and 4. Here 4 zeros are there. And for this polynomial, you can see 1 0 and 1 coincident 0, and again 1 0. So there are 3 zeros for this given polynomial. I hope you all understood what is the zeros of the polynomial, how to identify the zero of the polynomial from the given graph, and how to find the zeros of the polynomial in factorization method. Okay. Thank you, and we will meet in the exercise 2.